Nice to see you again. Let's move on to the next 20 questions. Question 81. A company decides to switch from using a 7 billion parameter language model to a much larger 70 billion parameter model for their application. According to AI scaling laws, what are the typical consequences of this change? Choose 2. A. The model will require significantly less data to train. B. The model's performance and accuracy will likely increase. C. The model will become less expensive to host and run. D. The model's inference time latency will likely increase. E. The model will be easier to deploy on edge devices with limited memory. Okay, this question is about upgrading from a smaller AI model to a much larger one. The core task is to identify the typical results or consequences of increasing a model's size based on its number of parameters. We need to choose 2 correct answers. Let's start with the incorrect options. Option A says the model will require significantly less data to train. This is incorrect. On the contrary, larger models typically require much larger amounts of data to learn effectively and to avoid overfitting. Option C says the model will become less expensive to host and run. This is also incorrect. Larger models require more powerful computational resources, like stronger PUS and more memory, to run inference, so the operational cost will increase. Option E says the model will be easier to deploy on edge devices with limited memory. This is incorrect. Large models are very difficult and often impossible to deploy on edge devices because of their high memory and processing power requirements. Now for the correct answers. Option B. The model's performance and accuracy will likely increase. This is a correct answer. This is one of the core principles of scaling laws. Generally, as you increase the number of parameters, the model's ability to capture complex and nuanced patterns in the data also increases, which leads to better performance and higher accuracy on many tasks. Option D. The model's inference time latency will likely increase. This is also a correct answer. A model with more parameters requires more calculations to make a prediction. Because of this, the time it takes to process a single request, its latency, will usually be longer compared to a smaller model, even when running on the same hardware. Question 82. A user gives a large language model the following instruction. Translate the following English sentence to French. Hello, how are you? The user does not provide any examples of English to French translations in the prompt. What is this type of prompting technique called? One-shot prompting. B. Fine-tuning. C. Zero-shot prompting. D. Few-shot prompting. Okay, this question is about interacting with a large language model using a prompt. Our core task is to identify the correct name for the prompting technique where you ask the model to do something without providing any examples in the prompt to guide it. Let's go through the options. Option A is one-shot prompting. This is incorrect. One-shot prompting requires you to provide one single example in the prompt to show the model what to do. For example, translate English to French. See otter-lutri de mer. Hello dash? Option B is fine-tuning. This is also incorrect. Fine-tuning is a process where you actually retrain a model on a new dataset, which involves updating the model's weights. Prompting is a technique for interacting with an already trained model without changing its weights. Option D is few-shot prompting. This is incorrect. Few-shot prompting requires you to provide a few examples, meaning more than one, in the prompt so the model can learn the pattern and give an answer. This leaves us with option C, zero-shot prompting. This is the correct answer. Zero-shot prompting refers to the ability of a model to perform tasks that it has not been specifically guided on with examples in the prompt. You simply give the model a direct instruction, and the model relies on its vast pre-existing knowledge to carry out the request. Question 83. In natural language processing, what is the primary goal of using text normalization techniques like stemming and lemmatization? A. To generate new sentences that are grammatically correct. B. To classify the sentiment of a text as positive, negative, or neutral. C. To reduce inflectional forms of a word to a common base or root form. D. To identify and categorize named entities such as persons, organizations, and locations. Okay, this question is about data pre-processing in natural language processing. Our core task is to identify the main goal of two common text normalization techniques, which are stemming and lemmatization. Let's go through the options. Option A is to generate new sentences that are grammatically correct. This is incorrect. This is the function of generative models, not the purpose of stemming or lemmatization. Option B is to classify the sentiment of a text as positive, negative, or neutral. This is incorrect. This is a description of the sentiment analysis task. Option D is to identify and categorize named entities such as persons, organizations, and locations. This is also incorrect. This is a description of the named entity recognition or NA task. This leaves us with option C, to reduce inflectional forms of a word to a common base or root form. This is the correct answer. This is the exact purpose of both techniques. Words like running, ran, and runs all share a common core meaning. By reducing them to a common root form, for example, run, we can reduce the complexity of the vocabulary and help a model understand that these words are fundamentally the same. This helps to simplify the analysis process and can improve a model's performance. Question 84. A developer is building a production-grade application that requires fast and efficient natural language processing for tasks like tokenization, part-of-speech tagging, and named entity recognition. Which of the following Python libraries is an industry-standard, high-performance tool specifically designed for these purposes? Pandas. B. Matplotlib. C. Spacy. D. Scikit-learn. Okay, this question is about building a production-grade NLP application that requires high performance. Our core task is to identify which Python library is an industry-standard tool specifically designed for efficient natural language processing tasks. Let's go through the options. Option A is Pandas. This is incorrect. Pandas is a library used for manipulating and analyzing structured, table-like data, not for processing language. Option B is Matplotlib. This is incorrect. Matplotlib is a library used for data visualization, like plotting charts, and is not related to NLP. Option D is Scikit-learn. This is also incorrect. Scikit-learn is a general-purpose machine learning library. While it has some tools for vectorizing text like TF-IDF, it is not a specialized library for deep linguistic processing tasks in the way that Spacy is. This leaves us with option C, Spacy. This is the correct answer. Spacy is a modern open-source library that is designed specifically for NLP applications that require high performance. It provides pre-trained models that are optimized for speed and accuracy on foundational linguistic tasks like tokenization, part-of-speech tagging, named entity recognition, and more. Question 85. What is the typical relationship between the ONCS format and NVIDIA Tensort in a model deployment workflow? A. Tensort is used to convert a trained model into the ONCS format. B. A model is often exported to the ONCS format, which is then used as an input for optimization by Tensort. C. ONCS and Tensort are competing standards that are mutually exclusive and cannot be used together. D. Both ONCS and Tensort are frameworks used for training neural networks from scratch. Okay, this question is about the deployment and optimization workflow for a machine learning model. Our core task is to understand the relationship between two technologies, ONCS and Tensort, and the order in which they are typically used. Let's go through the options. Option A says Tensort is used to convert a trained model into the ONCS format. This is incorrect. The process actually happens in the reverse direction. Frameworks like PyTorch or TensorFlow are the tools used to export a model to the ONCS format. Option C says ONCS and Tensort are competing standards that are mutually exclusive and cannot be used together. This is incorrect. They are not competitors. They are complementary. ONCS is all about interoperability, while Tensort is all about performance optimization. Option D says both ONCS and Tensort are frameworks used for training neural networks from scratch. This is also incorrect. Neither of them are training frameworks. They are both used in the stages after a model has already been trained. This leaves us with option B. A model is often exported to the ONCS format, which is then used as an input for optimization by Tensort. This is the correct answer. This describes a very common and standard workflow. ONCS acts as a universal intermediate format. You train your model in any framework like PyTorch and then export it to an .oncs file. Tensort then takes this .oncs file and performs a series of deep optimizations to create a very fast engine that runs efficiently on NVIDIA PUS. Question 86. Before fine-tuning a pre-trained language model on a new, custom dataset, why is it a crucial first step to perform exploratory data analysis? EDA? EDA is the process of deploying the model to a production server. B. EDA helps to understand the data's quality, identify potential issues like biases or anomalies, and inform the fine-tuning strategy. C. EDA is a technique used to significantly increase the number of parameters in the model. D. EDA is an unnecessary step as pre-trained models are already robust enough to handle any type of data. Okay, this question is about the process of fine-tuning a pre-trained model on a new dataset. Our core task is to understand and explain why exploratory data analysis, or EDA, is an important step to do before you start the actual fine-tuning. Let's go through the options. Option A says EDA is the process of deploying the model to a production server. This is incorrect. Deployment is the final step in the process, whereas EDA is one of the very first steps. Option C says EDA is a technique used to significantly increase the number of parameters in the model. This is also incorrect. EDA is the process of analyzing data. It is not a technique for changing the architecture or size of the model. Option D says EDA is an unnecessary step as pre-trained models are already robust enough to handle any type of data. This is incorrect and a very dangerous assumption. The performance of a model after it has been fine-tuned is highly dependent on the quality of the fine-tuning data. Even the most powerful pre-trained model will perform poorly if it's fine-tuned on data that is low quality or has problems. This leaves us with option B. EDA helps to understand the data's quality, identify potential issues like biases or anomalies, and inform the fine-tuning strategy. This is the correct answer. This is exactly why EDA is so critical. By performing EDA, you can check the quality of your data by looking for errors, missing values, or inconsistent formatting. You can detect potential biases in the data, which could affect the fairness of your model. And you can better understand the data's characteristics, which helps you make better decisions about how to prepare it and how to set up your fine-tuning process. The principle of garbage in, garbage out is very true here. Question 87. An insurance company uses an AI model to determine premium rates for customers. It is discovered that the model consistently offers higher rates to applicants from certain neighborhoods, even when their individual risk profiles are identical to applicants from other areas. This is an example of the model violating which key principle of trustworthy AI? Performance. B. Bias/fairness. C. Reliability. D. Privacy. Okay, this question is about an AI model that is making systematic decisions that unfairly disadvantage a specific group. Our core task is to identify the correct name of the trustworthy AI principle that is being violated when a model produces unfair outcomes. Let's go through the options. Option A is performance. This is incorrect. Performance refers to the speed or overall accuracy of the model. While a model might be highly accurate, it can still be unfair. Option C is reliability. This is also incorrect. Reliability means the model produces consistent results. In this scenario, the model is actually very consistent in making its biased decisions, but the core problem is one of fairness, not consistency. Option D is privacy. This is incorrect. Privacy is concerned with the protection of a user's personal data. The issue here is not that data is being leaked, but how the data is being used to make unfair decisions. This leaves us with option B, bias/fairness. This is the correct answer. This is a classic example of bias in AI, which leads to a lack of fairness. The model has learned an incorrect and harmful correlation from its training data, for example, historical data that contained discriminatory practices, and it is now reproducing that unfairness instead of evaluating each individual based on their own actual risk. Question 88. A bank uses a complex deep learning model to approve or deny loan applications. When a customer's application is denied, they ask for the reason. However, The bank is unable to provide a clear explanation because the model's decision-making process is too complex to interpret. This model lacks which important characteristic of trustworthy AI? Explainability/transparency. B. Scalability. C. Accuracy. D. Robustness. Okay, this question is about an AI model that is acting like a black box, which means humans can't understand the reasons for its decisions. Our core task is to identify the term that describes an AI system's ability to explain its decisions in a way that people can understand. Let's go through the options. Option B is scalability. This is incorrect. Scalability refers to the system's ability to handle an increasing amount of work. Option C is accuracy. This is incorrect. The model might be very accurate, but if its decisions can't be explained, it is still not considered trustworthy. Option D is robustness. This is also incorrect. Robustness refers to the ability of a model to resist attacks or small changes to its input. This leaves us with option A, explainability/transparency. This is the correct answer. Explainability, sometimes called XI or transparency, is a core principle of trustworthy AI. It requires that a model's decisions be interpretable, allowing humans to understand and trust the results. The inability to explain why a loan application was denied shows that the model is lacking this very important characteristic. Question 89. A company deploys an AI-powered image recognition system at the entrance of their building. The system works perfectly under normal lighting conditions, but consistently fails to recognize employees when it is a very sunny or a very cloudy day. This model is failing in which key area of trustworthy AI? Privacy. B. Fairness. C. Robustness. D. Transparency. Okay, this question is about an AI model that works well under ideal conditions but fails when there are minor changes or disturbances in the real-world input data. Our core task is to identify the term that describes a model's ability to maintain stable performance when faced with adverse or unexpected conditions. Let's go through the options. Option A is privacy. This is incorrect. The issue described is not related to the protection of personal data. Option B is fairness. This is incorrect. The model is not discriminating against a specific group of people. Rather, it is performing poorly for everyone under certain environmental conditions. Option D is transparency. This is also incorrect. The problem here is with the model's performance, not with the ability to explain its decisions. This leaves us with option C, robustness. This is the correct answer. Robustness, which is also related to reliability, refers to the ability of a model to maintain stable performance when it encounters noisy data, adversarial attacks, or shifts in the data distribution. The fact that the model fails because of a change in lighting conditions shows that it is not robust enough to work reliably in the real world. Question 90. In the context of a trustworthy AI model, which statement correctly defines validity and reliability? Validity refers to how fast the model makes a prediction. Reliability refers to how much memory it uses. B. Validity means the model produces consistent outputs for the same input. Reliability means the model's outputs are factually correct. C. Validity and reliability are the same and both measure the model's overall accuracy. D. Validity means the model's outputs are factually correct and measure what is intended. Reliability means the model produces consistent outputs for the same input. Okay, this question is about evaluating the trustworthiness of an AI model. Our core task is to identify the correct definitions for two important terms: validity and reliability. Let's go through the options. Option A says validity refers to how fast the model makes a prediction, and reliability refers to how much memory it uses. This is incorrect. Speed and memory usage are performance metrics, not the definitions of validity or reliability. Option B says validity means the model produces consistent outputs for the same input, and reliability means the model's outputs are factually correct. This is incorrect because it has the definitions of the two terms reversed. Option C says validity and reliability are the same and both measure the model's overall accuracy. This is incorrect. They are two separate concepts and cannot be used interchangeably. This leaves us with option D. Validity means the model's outputs are factually correct and measure what is intended. Reliability means the model produces consistent outputs for the same input. This is the correct answer. This is the precise definition of the two terms. Validity is about correctness. Are the model's results true? Is it actually measuring what it was designed to measure? Reliability is about consistency. If you give the model the same input multiple times, will it always produce the same or a very similar result? Question 91. The concept of power law generalization or AI scaling laws describes the relationship between the scale of a model, in terms of parameters, dataset size, and compute, and its performance. Which statement best describes this relationship? A. Model performance increases linearly with the amount of training data, without any upper limit. B. Model performance improves predictably as scale increases, but the rate of improvement diminishes. C. A model reaches its optimal performance with a relatively small amount of data, and adding more data provides no benefit. D. The performance of a model is completely independent of its size or the amount of training data. Okay, this question is about the relationship between scale and performance in large deep learning models. Our core task is to correctly understand the nature of the power law or scaling laws in AI. It's not just about bigger is better, but about how the model gets better as it scales. Let's go through the options. Option A says model performance increases linearly with the amount of training data, without any upper limit. This is incorrect. The relationship is not linear. If it were, doubling the data would always double the performance, which is not what happens in practice. Option C says a model reaches its optimal performance with a relatively small amount of data, and adding more data provides no benefit. This is incorrect. This is a common misunderstanding. Scaling laws show that for large models, adding more data almost always provides some benefit, even if that benefit gets smaller over time. Option D says the performance of a model is completely independent of its size or the amount of training data. This is incorrect. This statement is the complete opposite of what has been observed in the real world and what is described by scaling laws. This leaves us with option B. Model performance improves predictably as scale increases, but the rate of improvement diminishes. This is the correct answer. This is the most accurate description. The power law shows that as you increase the scale, for example by adding more data or more parameters, the model's loss will decrease in a predictable way. However, the benefit you get from each additional unit of scale gets smaller and smaller. For example, the performance boost from increasing your dataset from 1 billion to 2 billion tokens will be larger than the boost you get from increasing it from 10 billion to 11 billion tokens. This is known as the law of diminishing returns. Question 92. In distributed data parallel training, each GPU calculates the gradients for its own mini-batch of data. Before the model weights can be updated, these individual gradients must be aggregated and synchronized across all PUS, so that every GPU ends up with the same, averaged gradient. What is this collective communication operation called? Broadcast. B. Scatter. C. All reduce. D. Data augmentation. Okay, this question is about distributed data parallel training, which is a common technique for training large models on multiple PUS. Our core task is to identify the correct name for the collective communication operation that both aggregates data from all PUS and then distributes the final result back to all of them. Let's go through the options. Option A is broadcast. This is incorrect. A broadcast operation simply sends the same piece of data from one process, for example GPU 0, to all the other processes. It does not include a step where data is gathered from all the processes. Option B is scatter. This is also incorrect. A scatter operation takes an array of data on one process and splits it up, sending a different piece to each of the other processes. Option D is data augmentation. This is incorrect. This is a data preprocessing technique used to create more training data. It is not a communication operation between PUS. This leaves us with option C, all reduce. This is the correct answer. An all reduce operation combines two steps into one. First is the reduce step, where it collects data like the gradients from all the PUS and performs an operation on them, like calculating the sum or the average. Second is the all step, which is like a broadcast, where it sends the final result of that calculation back to all of the pus. This ensures that after the operation is complete, every GPU has the exact same synchronized gradient, ready for the next weight update step. This is a core operation in NVIDIA's NCA-GENL library. Question 93. What is the primary purpose of applying model quantization in a deep learning workflow? A. To increase the predictive accuracy of the model. B. To accelerate inference speed and reduce the model's memory footprint. C. To augment the training dataset with new synthetic examples. D. To train a model from scratch with fewer parameters. Okay, this question is about optimizing a deep learning model. Our core task is to identify the main purpose of the technique called model quantization. Let's go through the options. Option A is to increase the predictive accuracy of the model. This is incorrect. Quantization usually comes with a slight trade-off that can cause a small decrease in accuracy. Its goal is to improve performance, not accuracy. Option C is to augment the training dataset with new synthetic examples. This is incorrect. This is the definition of data augmentation, which is a data processing technique. Option D is to train a model from scratch with fewer parameters. This is also incorrect. Quantization is an optimization technique that is applied to a model that has already been trained. It is not a method for designing a new model. This leaves us with option B, to accelerate inference speed and reduce the model's memory footprint. This is the correct answer. These are the two primary benefits of quantization. First, it accelerates inference speed. By using integer math like int8 instead of floating point math like FP32, the model can run much faster on modern hardware. Second, it reduces the memory footprint. Using data types with fewer bits significantly reduces the model's file size and the amount of memory needed to run it. Question 94. A user provides the following prompt to a large language model. Translate English to French. See otter equals Lutry de mer. Cheese equals. This is an example of which prompting technique? A. Fine-tuning. B. Few-shot prompting. C. Zero-shot prompting. D. One-shot prompting. Okay, this question is about interacting with a large language model using a prompt. Our core task is to identify the correct name for the prompting technique where you give the model a single example to show it how to perform a task. Let's go through the options. Option A is fine-tuning. This is incorrect. Fine-tuning is a training process that involves updating the weights of a model. Prompting does not change the model's weights. Option B is few-shot prompting. This is incorrect. Few-shot prompting requires you to provide a few, meaning more than one, examples in the prompt. Option C is zero-shot prompting. This is also incorrect. Zero-shot prompting is when you give the model an instruction without providing any examples at all. For instance, translate the word cheese to French. This leaves us with option D, one-shot prompting. This is the correct answer. One-shot prompting is the technique where you provide exactly one example. In this case, C otter equals Lutry de mer, to teach the model the format or style of the answer you want. Right before you give it the actual request, cheese equals. Question 95. A developer is building a production-grade application that requires fast and efficient natural language processing for tasks like tokenization, part-of-speech tagging, and named entity recognition. Which of the following Python libraries is an industry-standard, high-performance tool specifically designed for these purposes? Pandas. B. Matplotlib. C. Spacy. D. Scikit-learn. Okay, this question is about building a production-grade NLP application that requires high performance. Our core task is to identify which Python library is an industry-standard tool, specifically designed for efficient natural language processing tasks. Let's go through the options. Option A is Pandas. This is incorrect. Pandas is a library used for manipulating and analyzing structured, table-like data, not for processing language. Option B is Matplotlib. This is incorrect. Matplotlib is a library used for data visualization, like plotting charts, and is not related to NLP. Option D is Scikit-learn. This is also incorrect. Scikit-learn is a general-purpose machine learning library. While it has some tools for vectorizing text like TF-IDF, it is not a specialized library for deep linguistic processing tasks in the way that spaCy is. This leaves us with option C, spaCy. This is the correct answer. spaCy is a modern open-source library that is designed specifically for NLP applications that require high performance. It provides pre-trained models that are optimized for speed and accuracy on foundational linguistic tasks like tokenization, part-of-speech tagging, named entity recognition, and more. Question 96. What is the primary purpose of the GLU, General Language Understanding Evaluation, benchmark in the field of natural language processing? A. To provide a large, unlabeled corpus for pre-training language models. B. To serve as a standardized suite of diverse NLP tasks for evaluating a model's general language understanding capabilities. C. To be a specific type of model architecture similar to a transformer. D. To be a software library for deploying language models into production. Okay, this question is about evaluating and comparing the performance of natural language processing, or NLP models. Our core task is to identify the correct purpose of the GLU benchmark. Let's go through the options. Option A says to provide a large, unlabeled corpus for pre-training language models. This is incorrect. GLU is a set of evaluation tasks. It is not a corpus or collection of texts for training models. Option C says to be a specific type of model architecture, similar to a transformer. This is incorrect. GLU is an evaluation benchmark, not a model architecture. Models that have a transformer architecture are often evaluated on the GLU benchmark. Option D says to be a software library for deploying language models into production. This is also incorrect. GLU is used for evaluation during the research and development stage. It is not a deployment tool like NVIDIA Triton. This leaves us with option B, to serve as a standardized suite of diverse NLP tasks for evaluating a model's general language understanding capabilities. This is the correct answer. This is the exact definition of GLU. It is a collection of several different NLP tasks, such as sentiment analysis, natural language inference, and identifying similar sentences, which are designed to measure a model's comprehensive language understanding ability. A model that achieves a high score on GLU is considered to have a good ability to generalize across many different kinds of language problems. Question 97. While both BLU and ROUGE are metrics used to evaluate generated text by comparing it to a reference, they are optimized for different tasks. Which statement correctly describes their primary use cases? A. BLU is for text summarization, recall-focused, while ROUGE is for machine translation, precision-focused. B. Both metrics are primarily used for evaluating the accuracy of classification models. C. BLU is for machine translation, precision-focused, while ROUGE is for text summarization, recall-focused. D. Both metrics are identical and can be used interchangeably for any text generation task. Okay, this question is about comparing two common evaluation metrics for text generation tasks, BLU and ROUGE. Our core task is to identify the main use case for each metric and to understand the key difference in how they work, which is the idea of precision versus recall. Let's go through the options. Option A says BLU is for text summarization and ROUGE is for machine translation. This is incorrect because it has the roles of the two metrics reversed. Option B says both metrics are primarily used for evaluating the accuracy of classification models. This is incorrect. Both are used for text generation tasks, not for classification. Option D says both metrics are identical and can be used interchangeably for any text generation task. This is also incorrect. They are designed with different goals and are optimized for different tasks, so they are not interchangeable. This leaves us with option C. BLU is for machine translation, precision-focused, while ROUGE is for text summarization, recall-focused. This is the correct answer. This is the exact distinction between them. BLU, or Bilingual Evaluation Understudy, focuses on precision. It measures how many of the words and phrases in the machine's translation also appear in the human reference. This is important for machine translation, where fluency and correctness are priorities. ROUGE, or Recall-Oriented Understudy for Gisting Evaluation, focuses on recall. It measures how many of the words and phrases from the human reference summary appear in the machine summary. This is important for text summarization, where the main goal is to capture all of the important points. Question 98. A user asks a large language model, "Who improved the light bulb after Thomas Edison?" The model confidently replies, "After Thomas Edison, the light bulb was significantly improved by Arthur Clarke in 1972, who developed the carbon nanofilament." Even though Arthur Clarke is a science fiction writer, and this invention is fictional. What is this phenomenon, where an AI model generates a factually incorrect or nonsensical statement but presents it as if it were true, called? Overfitting. B. Bias. C. Hallucination. D. Data poisoning. Okay, this question is about a situation where a large language model creates information that is factually wrong, but it presents it very confidently and fluently. Our core task is to identify the correct term for this phenomenon, where an AI seems to make up information that isn't true or isn't based on its data. Let's go through the options. Option A is overfitting. This is incorrect. Overfitting is a training problem that occurs when a model learns the training data too well and then performs poorly on new data. It doesn't specifically describe the creation of false information. Option B is bias. This is also incorrect. In AI, bias refers to a model producing systematically unfair results that reflect prejudices in the training data. While bias can lead to incorrect answers, the term hallucination is more specific to the act of creating non-factual information. Option D is data poisoning. This is incorrect. Data poisoning is a type of security attack where malicious data is intentionally added to a training dataset to sabotage a model. This is different from a hallucination, which is an emergent behavior of current models, not an attack. This leaves us with option C, hallucination. This is the correct answer. This is the exact term used to describe this behavior. An AI hallucination occurs when a generative model creates an output that sounds plausible and is well-structured, but is completely false or cannot be verified with real-world facts. It's as if the model is imagining or making up the information. Question 99. An e-commerce company wants to determine if changing the color of their Add to Cart button from blue to green will increase user clicks. They decide to randomly show the original blue button to one group of users, Group A, and the new green button to another group, Group B. Then statistically compare the click-through rates. What is this experimental method called? K-means clustering. B. Decision tree analysis. C. A-B testing. D. Exploratory data analysis, EDA. Okay, this question is about a company that wants to test a small change on their website, the color of a button, to see if it improves a specific business metric, in this case, the click-through rate. Our core task is to identify the correct name for this type of controlled experiment, where two versions, A and B, are compared against each other randomly. Let's go through the options. Option A is K-means clustering. This is incorrect. K-means is an unsupervised learning algorithm used to group data, for example, to find segments of similar customers. It is not a method for testing and comparing the performance of two different versions of something. Option B is decision tree analysis. This is also incorrect. A decision tree is a supervised machine learning model used to make predictions based on a series of if-then rules. It could be used to predict whether a user will click a button based on their characteristics, but it is not the method used to test which button version is better. Option D is exploratory data analysis, or EDA. This is incorrect. EDA is the process of analyzing existing datasets to summarize their main characteristics, often using visual methods. It's done to understand the data before you run an experiment or build a model. It is not the experimental method itself. This leaves us with option C, A-B testing. This is the correct answer. This is the exact definition of A-B testing. It's a controlled experiment where you compare two versions, A and B, of a single variable. Group A is the control group which sees the original version, the blue button. Group B is the variant group which sees the new version, the green button. By comparing the results from these two groups, the company can make a data-driven decision about which change is more effective. Question 100. In text preprocessing, Both stemming and lemmatization are used to reduce words to their root form. What is the key difference between these two techniques? Stemming is a more modern technique that always produces more accurate results than lemmatization. B. Stemming uses dictionary and morphological analysis to find a word's base form, while lemmatization uses simple rules to chop off word endings. C. There is no difference. Both terms refer to the exact same process and can be used interchangeably. D. Lemmatization uses dictionary and morphological analysis to find a word's base form, while stemming uses simple rules to chop off word endings. Okay, this question is about text preprocessing in NLP. Our core task is to identify the key difference between two word normalization techniques, stemming and lemmatization, based on their methods and results. Let's go through the options. Option A says stemming is a more modern technique that always produces more accurate results than lemmatization. This is incorrect. Lemmatization generally produces more linguistically correct results, and stemming is an older, simpler method. Option B says stemming uses dictionary and morphological analysis, while lemmatization uses simple rules to chop off word endings. This is incorrect because it has the definitions of the two techniques reversed. Option C says there is no difference and the terms can be used interchangeably. This is incorrect. They are two distinct techniques with different approaches and different results. This leaves us with option D. Lemmatization uses dictionary and morphological analysis to find a word's base form, while stemming uses simple rules to chop off word endings. This is the correct answer. This is the exact difference. Lemmatization is a more complex process that is based on linguistic knowledge. It analyzes a word to find its lemma, or its dictionary root form. For example, it knows that better becomes good, and that am and is both become be. The result is always a real word. Stemming is simpler and rule-based. It just chops off common endings or suffixes. For example, studies and studying might both become studi, which is not a real word. Thanks for watching. If you found this video interesting and helpful, please like, share, and subscribe to our channel. See you in the next video. Happy learning!